Good morning, all. Welcome to the ABL Maritime Market Briefing for February 2023. Sorry, we're a little behind schedule going online. We've had a couple of technical difficulties here in Lloyd this morning. My name's Mark McGurran, and I'm the Global Managing Director for Maritime here at ABL. Today, we're going to be talking about to tow or not to tow. So a very interesting presentation, and that, of course, will be followed by case reports later on. This briefing is accredited by the Chartered Insurance Institute, and delegates can claim up to 1 CPD hour for their participation. We will therefore keep a record of those of you logging on online, as well as those of you in the room today. So please contact us afterwards if you require a CPD certificate. I'm delighted to introduce our presenters for today. Giving the technical part of our presentation is Sean Murphy, who is a senior surveyor and marine engineer and naval architect. He's been in the game for over 10 years. He was a graduate of the Webb Institute in New York, and he joined ABL in February 2022. And quite a few of us at ABL worked with him previously in other companies, so we know him well. He's a senior surveyor, and he's based in our Boston office, and he came over to give us this presentation. So I'm very glad that a couple of minutes late we did get things working. Otherwise, that would have been a wasted trip. And he's been working with us in maritime and offshore wind in the US market. And he focuses on damage investigations for hull and machinery and P&I, warranty marine surveying, and offshore wind, T&I, and O&M consulting. And following that, Jasper Gaskin, one of our graduate engineers who is on our engineering development scheme, will be giving us the case reports. Jasper has a master's in mechanical engineering and graduated last summer and is here with us in London. Oh, sorry. Chatham House rules apply, the usual caveats apply. Any information contained in these presentations and any opinions or comments expressed are those of the presenters and not necessarily those of ABL. At the end of today's briefing, we'll ask you all to complete a short survey. It's very important if you could find some time to do this, because it helps us keep our accreditation status for the CPD points, which I know is useful for many of you. But of course, it also allows us to tailor our future presentations in the areas that you guys want to hear about. And just before I hand over, I'd just like to mention the Neptune Declaration on Seafarer Wellbeing and Crew Change. This is something very close to our hearts here at ABL. Many of us are ex-seafarers on the team. And although COVID's obviously starting to recede a bit now, and it's in the rearview mirror a bit, there's still plenty of issues around the world in repatriating seafarers and getting them the access to travel and the needs that they require. So if you're in a position to do so, perhaps you could take some time to take a look at this and get your own companies to sign up to it. And with that, I'm going to hand over to Sean. Very much.
Okay, good morning all. Thank you for being here today. I really appreciate it. We appreciate you all showing up, and my pleasure to be here speaking with you. So today I'm here to speak with you. Title of my presentation is To Tow or Not to Tow. Subtle reference there, Shakespeare. Obviously, we're in the London city. Couldn't resist a quick reference there. It was either that or All the World's a Tugboat, and just didn't quite fit as well. So hopefully you'll agree I went with the right choice there. But we're going to be talking about mitigating towage risks, learning from incidents, and the future of the market. And with that, we'll dig right in. So as these briefings are CPD accredited, just wanted to run through the criteria real quick about our learning objectives for today. So in terms of what you'll learn, I'll just read these verbatim right here real quick. By the end of the presentation, you will learn the process for a marine warranty survey of towage approvals. That's number 1. For 2, following the technical presentation, you will understand focus areas to mitigate risks, including tug suitability, voyage planning, and towage arrangements and preparation. During the technical case studies, you'll develop an understanding of towage liability risk. And by the end of the presentation, you'll be able to summarize where the future is headed for towage approvals for different assets, floating wind, foundations, and dry docks included. And with that, we'll start with a bang. The bad news first, right? Incidents happen. And I want to go into the incidents first, just to say, accidents do happen. There is risk. There's no way to avoid risk, right? There's a way to limit it. And with the marine warranty position, which I'm going to be focusing on today, marine warranty surveying, MWS. Our job is to limit it to to the most reasonable extent as possible. Limit risk to the most as much as possible. So just running through a quick hypothetical, real incident, but just some hypothetical questions as we go through. Put yourself in the captain's shoes. You're towing a barge, could be this asset, could be a deck barge with some cargo going into port. And you're going from A to B, you're almost at point B, going into the port. Maybe you didn't shorten the tow line soon enough, weather picked up, something like that. You went in daylight, nighttime hours when it should have been daylight hours. One thing led to another. Maybe you should have had an assist tug. Contact the jetty, end up with a salvage. This vessel, in fact, was ended up being refloated, but shows the risk. Fully laden, a lot of cargo involved, all that. So where does MWS come in is the question. And a couple more case studies before we move on to the meat of the presentation. The left side, hull damage, it doesn't have to be human error, right? A lot of that first slide was human error questions. Making decisions about the tow, making decisions about the timing. Hull damage, condition of the barge is another question. And then the right side, maybe you lose propulsion, lose the tow line. Condition of the equipment also comes into play. And marine warranty, again, we're there to limit the risk to the most reasonable extent possible. You can't avoid risk. If we could, none of us would be in a job right now, right? So we're there to limit risk to the most reasonable extent possible. And hopefully we can learn from incidents like this and apply them on the front end as an MWS. So a quick overview of the presentation. Again, to tow or not to tow. We just ran through the case studies briefly. We'll go through a quick introduction now, and we'll dive right into MWS. I'm going to break it up into 3 sections. First is the desktop, what we do in the desktop prior to the kind of game day work we do once we're on site doing the site inspections. And we'll lead right into the site inspections, and then next will be the voyage tracking. Once you sail away, keeping track of the voyage, any deviations, and so on and so forth. After that, we'll kind of review some risk and red flag considerations. This could be just general risks that we've seen, and also some recent kind of developments and requests we've seen coming up, and we just want to kind of reiterate some standpoints from our side on that. And then last but not least, future considerations, renewables and floating wind. As Mark mentioned, I've kind of been working a lot in offshore wind lately, so I couldn't resist a quick touch on that. And then last but not least, revisit objectives, and then a quick Q&A if we have some time. So diving right in, the ABL process, before we kind of go into the full desktops side, just want to kind of go through ABL process. Everybody has their own, but want to review how we go about it. First, we have an internal guideline, right? MWS towage approval guideline. This is reviewed periodically, updated. It's a resource internally for any MWS folks carrying out both wet towage and dry transportation. How we go about it, what are the processes, who's responsible, what is our remit, so on and so forth. So we keep somewhat of a standard, consistent process for all the work we do here. Once we get a job, towage risk assessment, we take it through a quick risk assessment just to assess, what's the tow, what are the conditions, what's the asset, our calculations being done, what's the risk of grounding, so on and so forth. We kind of calculate an initial risk, apply mitigation, what's going to be the post-mitigation risk, and then we use that as a guide to help evaluate things as we move through the towage process. And then also we have a technical checklist, is kind of to keep track, making sure we're checking all the right things, crossing our T's, dotting our I's, and then certificate of approval, the end deliverable for the MWS side. Once we're satisfied, all recommendations have been complied with. It could be multiple COAs for a single project, right? We could have loadouts, we could have towage approval, sail away, and so on. We'll multiple COAs, but that's again a crucial document in the process. So before we dive in, I know some folks might not be on mariners here, or have sailed or anything, but probably in the market for a while. Just in case, I want to just quickly review the anatomy of a tow arrangement. So first and foremost, you got the tug and the tow, and how do we connect those two? How do we bridge the gap? various configurations to do this. This is the standard for, say, a single tow, single tug operation. So first you have going back from the tug aft. You have the tug tow line. That's going to be probably the primary tow line, right? Cable on the tug. It'll go aft, connect to a pennant wire, usually via shackle, and then go to the tow fish plate. The tow fish plate's just a flat steel plate, 3 holes. One connects the tug's tow line, the other splits the tow force into 2 bridle legs that then connect to towing brackets, and that's how you get your tow connected. And that angle with the fish plate helps just in directionality for the tow. So towage approval and desktop work, I want to emphasize, is a very crucial area for us, right? As the saying goes, give me 6 hours to chop down a tree, I'll spend the first 4 sharpening my axe. This is sharpening the axe. This is where the whole operations team, the towage contractor, et cetera, should be focusing on how to get the tow done successfully, mitigate risk, and as MWS, we're there to kind of make sure that process is being carried out suitably to limit the risk to a reasonable extent. So kickoff, what's the vessel, what's the cargo, if there is any, and what's the voyage? Planning is crucial. Catch errors and issues early to mitigate. Don't want to wait until sail day. Issues may still come up on execution when you're doing those on-site investigations, but hopefully minor at that stage. You want to plan ahead and kind of get this done. Again, sharpen the axe so you can have a successful day when it's kind of game time. So start early and mitigate. Vessel particulars. So once you know what you're going to tow, question is, what are the vessels involved? If it's cargo, what barge are you going to use? If it's just an asset, maybe a rig or something that you're going to be moving, what are the particulars? What are the stability? What's the sailway condition? Get those assessed. What's the tow configuration? Start evaluating that. If there's cargo involved, again, that could be a whole separate presentation. But what's its position on deck? Is there sufficient deck strength? Securing and sea fastening, crucial elements that have to be evaluated, kind of put through an iterative process to make sure it's adequate for the tow. There's cargo stowage and securing, IMO code, CSS code is a helpful standard there to apply. Evaluate the sufficiency of cargo securing arrangements and planning. And then the last 2 items, review the tow transportation manual. So the tow transportation manual is kind of the guide, the overall guide for what you're going to be towing, right? Put together by the towing contractor. It's gonna outline the whole gamut of what's going to be done. What are the conditions? What's the tow? Who's responsible? Contact information. Where are you going? What's the rough voyage plan? So on and so forth. So we'll get into that a bit more in the next slide. And then depending on the cargo, if cargo is involved, and depending on the rig or whatever is being towed, tow route feasibility study may be required. That could include things like probabilistic evaluations, structural assessments. You can model that, evaluate that against mid-ocean criteria for whatever the voyage might be, point A to point B. Determine the success, what kind of weather windows you need. And again, that's just dependent on the level of detail and what's being towed. If it needs more structural kind of evaluation, you'll kind of go to that greater detail. So continuing with the desktop work, worth 2 slides because it's very important. So we go through the towage arrangement. We step in. This is kind of getting into some of the towage manual aspects, but towage arrangement in more detail. Configuration of the bridle. So that's that kind of triangular aspect connecting the tow line to the asset. What's the configuration of the bridle, pad eyes? What are the chain sizes, types, tow length, adequate tow length, evaluating minimum tow length. What's the calculated minimum that you need when you're under tow, and crucially emergency towing arrangements. Right, if something goes wrong, you lose a tow line. What's the alternative? What's the mitigation? So you can connect that emergency tow arrangement. Usually it's on a buoy, floating after the asset. You can pick that up quickly, get whatever you're towing back under control. Crucial arrangement to be made and implemented and executed. And preparation of the yacht, right? If you have a barge, if you're towing some cargo, more heavy lift, maybe there's grillage to be involved. Grillage meaning kind of the substructure that's going to be in between the barge and whatever the cargo is. So preparations of that side of things, what engineering has to be done, structural assessment again. And bollard pull estimations. So this is kind of, again, a crucial estimate. Once you have the asset, you know what you're towing, put it through a bollard pull calculation. This is usually done by kind of a marine advisor, marine technical consulting company involved, or it could be the tow operator. But you want to have continuous bollard pull tow, and it kind of varies depending on what the tow configuration is, what the exact operation is. Generally, it's you want continuous bollard pull for 20 meter per second wind. It's about 30 to 40 knot winds, half a knot current speed, things like that. So you want to apply that criteria. You can adjust the criteria depending on the specific tow. If it's inland versus ocean, so on and so forth. But again, a crucial element to determine what the required bollard pull is, and then you can size your tug appropriately, or tugs appropriately, for that operation. And then the voyage plan, right? Point A to point B. This is a sample on the right, just from a recent approval. My home port of Boston, of course. So voyage plan, point A to point B. You got waypoints. This is a higher level, right? This is not for navigation. Captain will have ECDIS, have charts, whatever he needs to kind of get this done. But voyage plan to just outline what's the point A to point B, what are the points of refuge along the way. If it's an inland like this, what's the mitigation in the event that you do lose the tow wire or something, weather comes up, so on and so forth. If obviously we're on the east coast of the US, you get into the southeast, hurricane waters, whatever, risks come up, what's the port of refuge that you can rely on in the event something happens. Estimated distance, duration, and from that we'll estimate a fuel requirement. You want to, again, kind of apply what the tug, the chosen tug is. Does it have adequate fuel reserves? And that's something you'll kind of assess through the voyage plan. And then we get to the on-site stuff, right? So the initial attendances, first one, suitability is the survey of the tug. So as I mentioned, you'll have the voyage plan, you'll have the tow transportation manual. Tow contractor will want to choose a tug, and our initial site visit usually is MWS is for the suitability survey of that. That should be hopefully done well in advance, right? If the tug is not suitable, if we go on site and say this doesn't have sufficient bollard pull or the conditions poor, you want that well in advance so they can kind of act appropriately and hopefully find an alternative or make rectifications as necessary. Towage arrangements, you want to go on site. This is usually closer to kind of game day. Once the sailway is kind of approaching, you want to assess the tow gear. Right gives just a sample bridle. Again, chain bridle with that fish plate, that yellow part right there is that fish plate, as I mentioned earlier. So you want to just assess the condition, make sure the chains are okay, no cracks, no deformation, not too much chafing. Steel condition is good. Things of that nature. Also the connections on the actual tow itself, if there's smit brackets, things like that, check them to confirm they're in good shape. And they'll be adequate for the voyage. And then through that process, again, you'll make recommendations. Maybe the tug has some defects that merit attention. Make those recommendations, discuss them with the captain, make sure they're implemented prior to the day the sail away is planned. And then again, ideally all these initial attendances, ideally well in advance, as well in advance as possible. It's often a little closer to the sail away time, but you just do that as well in advance so that there's sufficient time to act on those recommendations and implement them and comply with them. So we get to the sail away day. Again, you're on site, confirmation of proper execution. Those recommendations that you made for the tug, have they been complied with? Are there any other recommendations as you're going around? Any changes to the tug? For example, on the closer to the date, we've had that where you get closer to the day and then that tug wasn't available. It had another job come up because the schedule shifted. This new one's in, so we have to do another suitability. It's a confirmation, maybe a sister ship, something like that. Hopefully, it makes it a little simpler in terms of the suitability. But again, you want to check that condition, make any recommendations that are appropriate. And then you get to the COA, right? Certificate of assurance, certificate of approval. That'll include the warranted aspects, whether it's a single tow, no personnel on board, cargo, sufficient fuel for the voyage, how many days of fuel reserves you need, for example, so on and so forth. You want to note those in the COA, and then again specific weather limitations as well. What weather window do you need for departure? Maybe it's 7 days usually, give or take. And then what also daily progress reports. Once sail away takes place, part of the COA recommendations will be to provide DPRs on status of the tow. That'll include position, current speed, speed average generally past 24 hours, estimated time of arrival, condition of the tow, sea state, weather conditions, so on and so forth, fuel reserves, confirming that that's been being adequate for the voyage. In the event of deviations from this, right? If there's a change, partway through, maybe the tug has some experienced some difficulties. Crucial that the MWS is notified of that. Formal approval has to be provided by the MWS given any deviations. If not, then certificate of non-conformance can kind of come and then you kind of breach the warranty there. So crucial that we have early advisement of those deviations. And then also for us, once we know about those deviations, crucial that we kind of act on that as timely as possible. So getting into the risk and red flag considerations, we've kind of gone through the MWS process, right? The desktop review, the onsites, and the sail away. Some general risks and red flag considerations that we've come across. First and foremost, the obvious one, right? Vessel age and condition. If you go on site and the tug is not in good shape, what you're towing is not in good shape, condition. Recommendations can be made, rectifications can be made. Hopefully there's enough time to do that. Sometimes it's just in too bad a shape. That's again a big red flag, just to look at things in a bit closer view. Out of class. So if what you're towing perhaps is maybe it's a scrap tow, old vessel, out of class, again, there's just an added risk there. And also if what you're towing has not been designed to class, again, there's just a bit more risk there that you'd want to evaluate. Maybe there's some additional structural assessments you want to run the asset through to make sure it's sufficient for the voyage. Maybe the tow connection points are adequate, so on. Just some additional considerations to be made there. And fast requests. This one I don't love, but it happens, right? Unplanned fast requests. We need a marine warranty surveyor, right now. This isn't damage surveying, right? We get the call, something happened, we're on site, personal injury, whatever it might be. We're on site an hour after, as soon as we can after it happened. Marine warranty, there's a process, right? That desktop aspect is crucial, and it's crucial to get the MWS involved early so that we can review, make recommendations, and those can be complied with before sail away, so we don't have any schedule issues. Again, a general engineering principle that I love: if something does not look right, it often is not right. Right? Trust your gut, ask questions, and push back where you need. We're not trying to be part of the solution, of course, right? That whole adage, but again, just trust your gut, make calls, ask questions. And another aspect that we've had a bunch of inquiries on recently is the double and tandem tows, and I'll get into that now. So double and tandem tows will just run you through the configuration. So at the top we have a double tow, and this configuration, as you can see, it's just basically a single, same configuration as we showed earlier, but two instead of one, right? So two assets instead of one, same tow configuration. One's going to be a little bit further aft than the other. Fairly simple arrangement. The other one, we got the conga line, right? You got the towing vessel on the right, main tow line, same configuration for the first tow, and then after that connects to additional towing points, mid brackets, to another pendant line that bridges the towing point for the bridges and another bridle aft, and then connects to a second asset further aft. So we've been getting a lot of requests for these, and generally our policy is not to approve them unless it's more near shore and protected environments where help is readily available. From our view, I mean, these are generally higher risk. There's limited ways to mitigate in the event of a loss of tow. If you lose one of those tow wires, one of those assets kind of starts floating away on its own, is uncontrolled. It takes a pretty skilled captain to be able to reconnect that tow. You'll have emergency towing arrangements, but even still, if you're generally these things happen in sea conditions, it's rough weather out there, something like that, it's going to be pretty difficult to get that back under control. So fairly high risk, difficult to recover the tow line in the event of an incident. So for that reason, generally for ocean tows, we raise kind of a red flag there. it's just not really suitable configurations given the high risk. More appropriate for short distances, as I mentioned, benign areas, sheltered waters, near shore, and protected environments. You know, we've seen that done, for example, on more dredging type projects. You might have these configurations made, which is where it might be, you know, a bit more appropriate, where there's that sheltered environment. So quickly, touching on future considerations, just some kind of food for thought. We have floating offshore wind on the right. Obviously, the wind float. So this is just an example of one of the few that's been installed so far. So a few things I want to mention: high value assembly line projects in construction, operations, and maintenance. TTP is tow to port operations. So we have a few different aspects I just wanted to kind of touch on. Again, it's high value, right? This one on the right, you know, that's, I think, if I'm not mistaken, it's a 6 megawatt unit on the wind float farms. Today's value, it's about $1 million per megawatt for the wind WTG alone, the wind turbine generator. Fully assembled floating platform with the tower and integrated wind turbine. I mean, for this aspect, it's small. The ones on, you know, these next generation wind farms that are coming out, we're talking 18 megawatt units, 20 plus potentially. They're currently forecasting 21 megawatt units. So I mean, $1 million per megawatt, pretty high value. I mean, nothing out of the ordinary, but overall, you're probably talking with the floating substructure, $30 to $40 million risk, maybe higher. So fairly high risk, nothing out of the ordinary. But I guess the from my perspective, the difference comes in that assembly line approach. You're going to have, you know, probably a minimum of 20, probably on the high end, probably 70 of these in a single wind farm. Thousands of these units worldwide, and they're going to be integrated in port. You know, there's going to be some kind of an assembly line approach. You'll get the floating foundation, the yellow component alongside. You'll build the tower. You'll put the WTG on, ship it out to sea, and then you'll kind of keep that process going. And there's just going to be a lot of repetitive operations. So on the desktop side, right, for MWS, it's going to be fairly common between all those units. But on the towage out, you know, all these units are going to be the same design. But again, that on-site, I think, is going to be a little more crucial here to confirm that the towage arrangements are still being adequate. If they're being reused for each tow, just to make sure that there's not excessive wear being put on those items as the tow as the operation kind of continues. And these will, again, generally be under car policies, if it's O&M, operations all risk policy. But I think there's also, you know, towers liability risk there to consider if you have these on the hook. So all operators should kind of be aware of that, and just kind of evaluate things appropriately. Scrap decommissioning tows, I think those will continue, right? We have the rigs that are being decommissioned. You have ships, older tonnage, kind of getting shipped to the scrapyard. Some environmental considerations to be made there. Dry dock towage, we've seen a bunch of those past few years. Just shifting dry docks. They're unique, you know, assets to kind of move around. So again, just something to be mindful. It seems to be a continuing development. And port development, speaking of development, again, this can kind of flow back to the offshore wind side. A lot of port development, especially, you know, in the US where I'm coming from, it seems to be worldwide. A lot of ports being developed for offshore wind, offshore use. Supply chains are being developed. A lot of equipment moving from A to B. A lot of factories being developed. And just a lot of movement, a lot of different components being shipped around that take and each one should be evaluated, you know, in its own way. And as always, larger ships, larger equipment. I don't know what the ceiling is for some of these larger ships. But again, with these larger container ships, you have larger equipment. Container gantry cranes are getting bigger. So again, same kind of process. You want that desktop review, carrying out the structural analyses. But just some additional developments to be made there. So that's my tome. Recap of today's learning objectives again, just briefly. Hopefully, I've given you a good overview of marine warranty surveying for towage approvals. You should now be able to describe the process for MWS of towage approvals, understand the focus to mitigate risks, including tug suitability, voyage planning, and towage arrangements and preparation. Understand towers liability risk and some case studies that we've seen. And you should now be able to summarize where the future is headed with some food for thought there. And with that, I'll take any questions if we have time. Probably maybe. Do we have time for one or two? Do questions afterwards? Okay. Yeah. Sounds good. All right. Thank you for listening. Cheers, Sean. Thanks very much. Hi, everybody. On to the next section of this presentation, which is case reports for last month. So the purpose of this section of the briefing is simply to keep you updated on some of the recent high-cost incidents that ABL have been involved in, and in doing so, show you or remind you of the sorts of incidents and casualties that can happen in shipping and marine operations. But in case some of you haven't attended these briefings before, you might be asking yourself, what are these so-called case reports? Well, these feature largely, but not exclusively, hull and machinery casualties with estimated costs of repair in excess of $250,000, usually excluding salvage costs. They cover only a subset of the total ABL Group caseload, which is typically in the order of 10%. However, this is an important subset which represents about 25% of the hull and machinery cases by number, and around 65 to 75% of the hull machinery cases we survey by cost. Treat with caution, though. Estimated costs are often preliminary and subject to further inspections and/or investigations. In presenting these case reports for the last month of activity, it's not about attributing blame. We just aim to convey what happened. So we won't be giving any definitive conclusions about cause, as many of the cases are still fresh. It wouldn't be appropriate to do so. And in many cases, the cause is still under investigation anyway. As usual, let's start off with some statistics. I've been notified of 13 high-cost cases during January, and the blue columns in this graph show their proportional distribution by casualty type. 5 machinery cases, 1 each for groundings, explosions, sinkings, structure, tail shafts and coatings, and 2 in the other category, 1 being a winch damage on a fish factory vessel, and the other being damages to a small vessel under tow. As always, with such a small sample set, you are bound to have the gaps, some gaps in the distribution when you compare it to the distribution for a whole year. In this case, the whole of 2022, given as the grey columns. It's worth note that I'm still using the provisional figures for 2022, as the data for any missed cases is not yet available. Now, here we have added in the distribution of those same 13 cases by their total costs. Note that the structure and coatings cases this month are both relatively expensive, in contrast to the sinking case, which is disappointingly cheap. Well, disappointing from the point of view of statistics with a bit of drama, that is. Again, this month, the sinking case involved only a small vessel with a relatively low insured value. The total estimated cost for the 13 cases is about $9.1 million, and that makes the average cost of the high-cost cases for January around $700,000. This is lower than the typical annual background expected figure that we have seen over recent years of about $1 million per high-cost casualty, when individual extreme cases of over $50 million are excluded. Needless to say, we have had no such extreme cases this month. Let's move on to look at some of the January cases in more detail. We've selected 6 of them if we have time to go through them all. And bear in mind that although we say these are actually January cases, the month generally refers to when the first advice comes in from our surveyor. Some of the cases, therefore, may actually be from earlier months. To kick us off, we have this 15-year-old feeder container ship that got a bit of a surprise when she was dry docked in the Middle East for special survey. Although things may look fine from a distance, getting up close would reveal significant areas of wastage on the hull plating and welds. As most of you will know, ships are designed so that they have sufficient strength to resist the bending, twisting, and pressure effects in the worst sea conditions that they could experience in their lifetime. With their design scantlings of plate thicknesses, etc., in theory, a ship should not succumb to any form of localized or catastrophic structural failure. Being practical, though, in order to account for the sort of unavoidable corrosion that a ship's hull will experience during its lifetime, design scantlings will include a couple of millimeters or so extra based on normal rates of corrosion of reasonably maintained steel hulls in water. Obviously, for safety's sake, normal corrosion rates cannot simply be assumed, and so actual thicknesses of plating and stiffeners are checked and measured every 5 years at special survey, and often at intermediate surveys too for older ships. So getting up and close to our container ship, here we see the port side midships region. Gaugings of hull thickness were taken, and the diminution of many of the affected areas of side shell and bottom plating was found to have increased from a reported average of 1.5% in 2017 to up to 25% now. Some localized areas were worse. 186 plates of various sizes and thicknesses were identified as being below class allowable limits and would have to be renewed. About 240 tons worth of steel and heading towards $2 million worth in costs. Subsequent grit blasting of the hull created or revealed about 30 holes in the hull for good measure. About a month before the special survey, a hole in the bow thruster tunnel was discovered. I understand now that the whole tunnel housing needs to be replaced, but this will be deferred to the next scheduled docking later in the year. In the meantime, the thruster has been removed and the tunnel will be blanked on both sides. Below the thruster tunnel, you can see clear areas of deep pitting and some nasty looking galvanic attack on some of the weld seams. It's not just the thickness of the plating that's important for a hull's strength. The welds between them are also very crucial. Here's also a view of a deep pit on the bottom plate. Let's take a closer look with a tape measure. 15 millimeters deep, which is probably about 40% reduction in thickness. Here is a marked up shell expansion drawing showing all the plating that needs to be renewed. Owners have asked class if some of the renewals can be deferred until the scheduled docking later in the year so that they can resume trading sooner. Otherwise, they would be in dry dock for another 30 days. We understand that class have allowed this. So I understand about 100 tons are being replaced now, with a balance of 140 tons with less severe diminution to be cropped and renewed in November 2023. Here we see some of the marked up plating for renewal now on the port side. Similarly on the starboard side and turn of bilge. Here's a closer view of the pitting corrosion on the plating. Oops. Here is a closer view of the pitting corrosion on the plating structure. And you can see again the attack on the welds, which tend to be more prone to galvanic action like this. And here we see cropping commencing on the turn of bilge. Note that the internal stiffeners in this area are okay and do not need to be replaced. And a reminder that it is possible to crop out and replace outer plating without having to renew internals, in case someone tells you otherwise. There seems to be significant corrosion wastage almost everywhere. Here you can see it on the sole plate of the rudder. And here we see that about 3/4 of the bulbous bow has to be replaced. Investigations into the cause of all this and when and over what period it occurred are still underway. Samples of the excessively corroded steel have been sent for metallurgical analysis and the results are awaited. I understand that the ship's impressed current cathodic protection system was found to be in order since the present owner took over the vessel in February 2022. Whether there was any problem or extended breakdown of the protection system prior to that is being looked into. Okay, next up, and way down in the size scale, we have this small aluminium-built commercial fishing boat that experienced an explosion from within her hull while tied up alongside for maintenance. Fortunately, no one was on board at the time. The explosion caused the seacock hoses to be blown off and allowing seawater to enter the vessel, but there was no loss of any fuel or oil into the sea. Here we see her recovered and out of the water on a road trailer. We can see a split on the port side of the hull, but from this angle, she doesn't look too bad. Likewise, from this view on the starboard side, okay, there's other split, but it looks repairable, surely. But the damage is rather more extensive. The damage has extended upwards, distorting the wheelhouse roof and the bimini or canopy aft of that. Solar panels have been badly damaged also. But if we took over the side and into the craft, we can see a more telling view of the extent of damage. The main deck has been blown upwards and burst open, with the aft bulkhead of the wheelhouse in way being buckled. The likely explosion source was traced to a lithium-ion battery pack located under the wheelhouse area. If damaged in some way, the cells of these batteries can give off flammable gases. The costs quoted here are effectively for replacing the vessel and its onboard equipment, as it is looking increasingly unlikely that it will be commercially viable to repair the hull. Looking at these pictures, it was rather good fortune that no one was working on her at the time. This 4-year-old oil and chemical tanker had loaded a mixed cargo of vegetable oils in the Far East and was bound for Europe when they discharged the first parcel of one particular oil in a Mediterranean port. However, the cargo tank coatings, which are supposed to be inert to the cargo and protect the underlying steel structure, were found to be extensively damaged. Let's follow our attending surveyor as he looked around the various tanks once the ship had been discharged. Here is what a typical access to a tank looks like. It looks a bit like a toilet, though. I hope no one has made that mistake. Fortunately, for those who don't like heights or ladders, there's a nice stage stairway system rather than a vertical ladder. Here we are in the number 6 port cargo tank, which wasn't carrying the problematic cargo. So this is what the tank coatings should look like. All looking nice and fresh, tidy and clean. But alas, here is what the number 1 starboard tank looked like looking forward. Severe coating damage, largely detached up to the cargo loading level. Here's a closer view of the centerline bulkhead. And here a closer view of the starboard longitudinal bulkhead with the double hull space on the other side. Conditions were found to be much the same in number 1 port, as we can see looking down from the top gantry level. And a similar story in the number 5 tanks and slope tanks, where the problem cargo was also carried. Here we see the aft bulkhead of the number 5 port tank with 90% of the coatings lost. Note the nice staged stairway system that I mentioned. Here, the lower part of the starboard bulkhead, the coatings have largely detached from the top of the cargo level all the way down to the tank top. And here is the upper part of the starboard bulkhead. Here you can just about see the intact coatings above the cargo filling level and on the deck head above. And the forward bulkhead is the same. Moving into number 5 starboard, it's a similar story. This is the aft bulkhead. And here's a close-up of the starboard hopper plate. And here is the tank top. Hang on, doesn't that look too bad or not too bad? Interestingly, while the coatings of the tank tops in many of the affected tanks looked intact from a distance, they were all very soft, effectively destroyed, and couldn't be scraped off easily. Possibly gravity helped keep them in place, or perhaps there was some stratification in the cargo, with a less aggressive mixture at the bottom. Finally, here's a nice view of the undamaged portion of the portion above the cargo level and on the deck head. But this is academic to some extent. In order to repair all this before new coatings are applied, each cargo tank will have to be grit blasted, and it's very difficult to be delicate and selective about that. So the deck heads will have to be blasted and recoated too. In terms of costs, we're possibly heading towards a couple of $1 million again on this one. And in terms of cause, well, that's still very much under investigation. Was it an approved cargo? If so, was its composition within allowable bounds? Was it properly declared? And were any required temperatures maintained, etc., etc.? Okay, moving on. This 2-year-old high-speed catamaran ferry with passengers on board was approaching a port in the Far East at about 5 o'clock one morning. The third officer was on duty on the bridge at the time and had instructed the helmsman to alter course to starboard a bit to carry out a port-to-port passing of an oncoming vessel that was departing the port. As the vessels passed each other our catamaran here experienced strong vibrations and distinctly unpleasant noises as she suddenly slowed to a halt. I understand that all this commotion woke up the master, who happened to have been asleep in the navigation console chair, and he stopped the engines immediately. The vessel had grounded on a drying reef. They ran the engines astern to try to get her off, but with no success. By midday, the passengers were disembarked and a tug had arrived to assist. Following a diving inspection that revealed no obvious damage or entanglement in the reef, the tug was able to pull the vessel clear. The catamaran was then able to get herself safely into port alongside until inspections and repairs could be arranged, which is where we see her now, about a week later, pulled up on a repair yard slipway using roller airbags. The first bit of good news is that there is no obvious sign of damage to the starboard hull, at least. Note here that we are standing under the vessel between the hulls and looking off afterwards. The vessel has 4 engines and 4 propellers, 2 sets, inner and outer, for each hull. You can see just about that the starboard inner propeller and shaft have been removed. Likewise here, no apparent structural damage to the port hull, only some anti-fouling coating scratches to be touched up. But again, you can see the port inner propeller and shaft have been removed, and that is because both inner propellers have suffered contact damage, as we will see shortly. To help orientation, here is a view of the undamaged port side outer propeller with its rudder. On the other far side, the starboard outer propeller suffered some very minor tip damage, which was possible to repair. While the tip damage to the inner propellers necessitated their complete renewal. As you would expect, both inner shafts had to be withdrawn and checked for alignment. And here we see the reinstallation, showing one of the new inner propellers and the repaired starboard outer propeller. They were probably lucky to get away with just $300,000 worth of damage. As to the possible contributors to the cause, well, I understand that the electronic navigation chart on board was not up to date and was not giving depth information on the display. Also, while the approach to port was a buoyed channel, the red lateral buoy marking the reef was not lit at the time of the incident. Needless to say, neither of these conditions have helped the situation. This very elderly deck cargo barge, owned by a piling construction company in the Americas, was tied up alongside several other barges at their riverside base when all personnel departed for their Christmas break. On Christmas Day, a windstorm, quite common to the area, was plus a very high tide, caused all the vessels to break free of their moorings and drift out into the river. Our barge here went aground, sprang several leaks, and sank, leaving only the top of the bin walls above the surface at high water. And there she remained for several weeks while they waited for the next low tide to get access to the hull for temporary sealing and dewatering, and then hopefully refloating with the rising tide. And this is where we see her now, at the beginning of that operation. Unfortunately, the whole recovery process took place in the hours of darkness, so things aren't terribly clear. Here we see her at low tide, where she is still aground and listing, but nicely accessible for installing pumps and starting the dewatering process. And here, though, it doesn't look that much different. The operation has been successful. The pumps are effectively overtaking any remaining ingress, and the barge is now stable and afloat with the rising tide. It all sounds like a success story, but sadly, it looks like repairing the poor old barge will not be economically viable. I understand that her insured value is only about the same level as the threshold for getting into our case reports, about $250,000. And finally, let's look briefly at an auxiliary engine damage on this Aframax crude oil tanker. While at anchorage at a European port, the crew carried out a 10-day scheduled overhaul of the number 2 diesel generator engine, as per the manufacturer's 16,000 running hours maintenance program. Upon completion, the generator was run on idle for about 1 hour and then stopped and allowed to cool down. The crankcase doors were opened and bearings, bolts, conrods, and so on were internally inspected. As all was found to be in good order, the crankcase doors were fixed back on. The generator was then started again, then put in parallel with the already running number 3 generator, with the electrical load kept low at 25%. After 1.5 hours running at this load, the overhauled engine started to vibrate and make rather unpleasant noises. No alarm sounded though. The engine was immediately stopped by the chief engineer. Investigations revealed that, sadly, the engine had suffered heavy damages to the number 2 unit. It looks like the big end bearing bolts failed, causing the conrod to become detached from the crankshaft, which in turn battered the crankpin, broke the cylinder liner, and bent itself in the process. Again, in this case, the cause is still under investigation, awaiting metallurgical testing of the broken bolts to see if any of them had some form of latent defect. Other possibilities being looked at are incorrect tightening of the bolts during assembly or some blockage to the lube oil supply, although I understand there is no obvious evidence of seizing of the big end bearing. A large part of the repair cost here is the need to renew the crankshaft. Once one is delivered in 5 months' time, that is, plus the grinding of the damaged crankshaft in the meantime to allow them to operate the generator at lower loads until then. Well, that's all we have time for this month in terms of case studies. I hope they have been of some interest to you all. And let me hand back over to Mark to close us off.
Thanks very much for that, gents. They're both very interesting talks. So I don't know if he's in the room. Has he left? Where's Danny? No, he's gone. Right, so we have a prize winner from last month. So with our feedback forms, we'll ask some questions from today's presentation, and the prize is a bottle of champagne. And if you're here in person, you also get a box of chocolates. We bent the rules slightly today. Danny Wells won last month, and he was here until about 10 minutes ago. Oh, no, he's there. He's there. I thought he'd gone. No, so he said he had to leave at 10:30. We finished a little bit early today, so we gave the prize to Danny when he showed up this morning. So he's already got that. So congratulations to Danny. We'll be back next month. I'm not sure the date yet. We'll get that information out. And please do fill out the feedback forms if you do get a chance. Thanks very much for coming, and thanks everyone for logging on online. Thanks, everybody.